This is Algebra 2, Practice Quiz 7.4. In the initial instructions, we're asked to just solve by taking square roots. So let's jump in. The general idea for each of these problems is to get this p to the power of 2 by itself, meaning this pesky minus 10 is going to have to move to the other side. The way that we do that is by doing the inverse operation, adding 10 to both sides, meaning that I now have p squared is equal to 36. From here, I need to undo this square, and most people mistakenly think that the way that we do that is by just taking the square root of both sides, which is more or less correct. Let me go ahead and move all this stuff over a little bit. That isn't completely the truth. That doesn't have enough power. You have to actually do the plus or minus of it, and now it has the power to cancel everything out. So you're gone, you're gone, you're gone. Leave me with just a p. And on the right side, I have the plus or minus, and I can actually do the square root of 36. The square root of 36 is 6, and to get my final answer. So I know that the back of the practice quiz is not going to have this exactly. It'll probably say something along the line of the set of numbers containing, I don't know, does it start with negative? Probably 6 and negative 6. Doesn't matter the order. Sets don't have any order. So both of these are considered correct, although what is more common in my classroom is to do the plus or minus 6. Let's see what the backside says here. Yeah, 6 and negative 6 for the set of numbers. I'm just going to go ahead and write them like this for the rest of the practice quiz. For number 2, let's go ahead and, again, we're trying to isolate this x squared, meaning that this pesky 10 is going to have to move to the other side. Notice 10 is being multiplied by the x squared, so the inverse operation of multiply is to divide both sides by that 10. When I do that, 10s are gone, and that leaves me with an x squared by itself, and that's going to be equal to negative 6. And from here, I'm going to do the plus or minus the square root on both sides. So plus or minus the square root on the left side and plus and minus the square root on the right side. And this now has the power to cancel, 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 leave me with an x is equal to the plus or minus, and unfortunately I have a square root of a negative. The shortcutty method of doing this is just to say, oh, well, there's an I that pops out, and then you can leave the square root of 6, but let me explain why we do that. What's really happening here is this is going to be equal to the square root of two things. It's going to be equal to the square root of negative 1 times 6, which is really equal to the square root of, I should do the smaller, square root of negative 1 times the square root of 6. You're allowed to break up square roots like this. And the square root of negative 1 is I. The square root of 6 just was brought down here. And that's as far as we can go. Sometimes you can simplify this square root, like if it was a square root of 8. You could have said, oh, well, it's the square root of 4 and the square root of 2, and then this turns into 2, and the answer would be 2 square root of 2. But that's not the case right now. I have just 6 by itself, so can't go any farther. I mean, the factors are square root of 3 and the square root of 2, which are both prime numbers. There's no copy, so that's my final answer. And I'll go ahead and box this. And that was a weird box, but whatever. Let's see, plus or minus I root 6. Yeah, so I root 6 and negative I root 6 is the same thing, so I got it right. What about for number 3? Again, same steps as before. We're just trying to isolate the x squared by itself. So get rid of this 1, get rid of this 8 in that order. So we're going to add 1 to both sides, add 1 to both sides. That gives us an 8. Ooh, come on now. 8x squared is equal to 640. From here, we need to divide both sides by 8, divide by 8, divide by 8, and that's going to leave me with x squared is equal to, well, I'm going to ignore the 0 for a sec. 64 divided by 8 is 8, and I'll put that 0 back on. And from here, I need to take the square root, not just the square root, but the plus or minus square root. So I'm going to go ahead and move you over a little bit to give me some room to write the plus or minus square root, plus or minus the square root, plus or minus the square root. And that means you're gone, you're gone, you're gone. And I should really be doing this in a different color. I can say that this is, let's undo this. You're gone. So x is now by itself, and it's going to be plus or minus. Well, how do we do the square root of 80? So the square root of 80 for the factor tree, let's pull out a perfect square. Maybe you just see like a small perfect square like this. You say, oh, well, 4 is a small perfect square that I can pull out. 4 and 20, right? Because 4 is a nice number. This just goes to 2 with no square root. That would be cool. And then I can keep going with the square root of 20. Be like, oh, yeah, that's right. There's another 4. And then 4 times 5 is 20. So the square root of 4 times the square root of 5 is the square root of 20. And again, that 4 goes to 2. And I can't go any farther with the square root of 5. So I can go ahead and now rewrite this. This is equal to 2 times 2 times the square root of 5. And more simply, this is just 4 square root of 5. So I can come down here and say this is plus or minus 4 square root of 5 for my final answer, which I will then box. Let's check. Plus or minus 4 root 5, positive 4 root 5, negative 4 root 5. I got the right answer. All right, second section. Now we're going to solve by factoring according to the instructions. So the general step is make sure that we have a 0 on that side. Cool, done, check. Make sure you can, there isn't anything you can divide by. I can't divide anything, or I can, but nothing will come out evenly. So step 2, I don't have to do anything. Now step 3 is to actually do the factoring. And because we have this, there's no number in front of the x squared, you assume that that number is a 1. And you can do a normal ninja star. So the normal ninja star states that if I'm going to put a negative 2 for what they add to, and I'm going to put a negative 35 for what the two numbers will multiply to. So what two terms multiply to negative 35 and also add to negative 2? And I'm starting to go through all the factors. Normally this is where it's really helpful to have a multiplication table. I can pull that up in a sec if I need it for one of these problems. But for now, I'm just going to go through it one by one. I can say, okay, 1 times 35. That's not going to help us. And one thing that's kind of nice to note is because this answer is a negative, we know one of them is going to be a positive, one's going to be a negative. And because those are opposite signs, when I add them, you're really subtracting them. So when I'm subtracting these numbers, I should somehow get a negative 2. So a long-winded way of saying, don't add these two to get 2. You're going to be subtracting them to get the 2. What about... there's another one, 5 and 7. Oh yeah, that's the answer. So 5 and 7, one of them has to be negative. Remember, when we add them, we take the sign of larger, which means the larger one has to have that sign. You can say negative 7. And then I can go ahead and continue factor this thing and say, yes, this was x plus 5 and x minus 7 is equal to 0. And we've done a bit of factoring, but just as a reminder, that was a positive 5. This was the negative 7 coming down here. And then I can split this up. This is using the zero product property, basically stating that if I have something times something else, if this is 0, that's a solution. If this is 0, that's a solution. So let's say that that is 0. So I can say, what if x plus 5 was 0? That would be a solution. What if x minus 7 was equal to 0? That would be another solution. And then we just solve each of those. So subtract 5, and you get x is equal to negative 5. I could add 7 and add 7, and I get x is equal to positive 7. And those are my answers for number 4. I think, let's check, negative 5 and 7 for number 4. Negative 5 and 7 for number 4. The order doesn't matter. It's just those are the two answers. All right. Number 5, again, same 2 steps to start us off. I kind of want this side to be equal to a 0, so this pesky minus 8 is going to have to move. We're going to say we are adding 8 to both sides, and you don't put 8 right here because these are not like terms. I would write the 8 underneath the 12 because those are my, whoa, that's an 18. Those are my like terms. So you're gone, leaving me with a 0 on the right-hand side, which is our initial step. I have a 20 here, a 39r there, and a 7r squared here. All right, second step. Can I divide each of these by a number? Can I divide them all by like 7? No, 7 doesn't go into 39. In fact, I'm pretty sure 39 is a prime number, which means I can't divide any of these by anything evenly. They would come out to gross fractions or decimals, which means it's time for some sort of a ninja star. And notice that the difference between number 5 and number 4, this one had a number, a coefficient out front of our r squared term, and this one didn't. It was just a 1, which means in this problem, I need an advanced ninja star. So let's go ahead and set that problem up. Advanced ninja star, let's go. So ninja star. Okay, what 2 terms add to 39? And this is the tricky bit. Most people will say, oh, they're gonna, and I can write this up here because it is correct. You're gonna multiply, and then here's the incorrect thing that you would not copy down, 20. That's incorrect because what you're actually supposed to do is you're supposed to multiply the first and last term here, and that's going to give us 140. So I can write in here 140. Let's make sure I got my signs correct. Positive times positive is a positive. Positive comes down here and makes positive. Okay, everything's positive. And finishing setting up our ninja star, we have a 7r and a 7r. Just as a reminder, it's 7 and r that both come into each of these terms, so that one and this one. All right, so I'm finally ready. I'm asking what number here and what number here multiply to 140 and at the same time add to 39. And I'm not sure. I think it's 35 and 4. Yeah. But I think a lot of students struggle on these bigger problems, like 140. I don't know factors of 140. How would I do that? And I will show you. So let me go over here to my fun math page instead of my Algebra 2 page. And let me add in a page factoring table that I gave out to everyone. So give me a sec to import this. I believe I threw it into here. I think I called it like a multiplication table, MLM multiplication table. Let's go ahead and open you. So typically, this is what I give out. So here's our problem, right? We're asking first, what two things multiply to 140, and at the same time add to 39. Because this is a positive number, we do know that this number and this number are going to be added. Like, I know I say add, I really should use the word combine down here, because sometimes this is a negative and this is a positive, which means you subtract, but this is really adding. These two numbers are adding because that number is positive. So I'm going to first find 140, and then I'm going to say, okay, do those two sides add up to 39? I'll show you what I mean. 140. So let's zoom in here and look for 140. And the first thing that pops out is like, oh, there's 140, but 140 came from 14 and came from 10. Unfortunately, 14 plus 10 add up to 24. That doesn't add up to 39. So let's try again. We're searching for 140. I'm seeing 140. Oh, that's kind of the same thing, though, because this 140 came from 10 and 14. So searching for another 140, 140, 140. Okay, I see 140 right here. That's a 28 and 5, which adds up to a 33. Darn, that's still not quite right. So keep searching for 140, 140. And, oh, okay, finally I found one. 140 went, okay, you can't even see it, but now we can. So this 140 came from 4 and 35. And notice that 4 and 35 and 4, those do add up to 39. So my answer must be 4 and 35. I'll come back over here and say the answer here is 4 and 35. Just double check. 4 times 35. It's kind of hard to check that counts up to 140. I'm just going to trust the multiplication table on that. But do they add up to 39? And yes, they do. 5 plus 4 is 9. So from here, I'm going to reduce this fraction. This fraction is the fraction 7r over 4, which, I mean, they're coprim. 7 and 4, I can't reduce that any. But 7 and 35, I can reduce. I can reduce this by dividing both the numerator and the denominator by 7. So when I do that, I'm going to get r over 5. And I'm now ready to kind of factor this thing. So I can bring this one down here, and I'm going to say r minus 5 is one of the factors. And the other factor is going to be this 7r plus 4, 7r plus 4. And I still have this thing equal to 0. I'm just copying down that right-hand side. So just like in number 4, I can say if this is equal to 0, that would be a solution. And if this thing is equal to 0, that would be a solution. So I say that. I say r minus 5, that could be 0. That is a solution. And I say 7r plus 4, that also could be a solution. So when I add 5 to both sides, and that's going to give me r is equal to 5. And when I subtract 4 on both sides over here, that's going to give me 7r is equal to negative 4, which is not done. I need to solve for r, not just 7r. And from here, I'm going to divide by 7, divide by 7, and get r is equal to this fraction, negative 4 sevenths. So those are my two answers, negative 4 sevenths and 5. 5 and negative 4 sevenths, please. Ooh, I've messed up. Look at that. I got the negative 4 sevenths, but I didn't get a positive 5. I got a negative 5. So what did I mess up on? Check. Oh my goodness. Do you see that? That's pretty embarrassing. This was the mistake. Pause the video now. Make sure that you find the mistake. If you find the mistake, it is extra credit, as always. And now I'm going to tell you. So if you are listening to me telling the error, then it doesn't count as extra credit. I'm telling you, this is a mistake. From here to here, for some reason, I'm like, that's a negative 5. But that's a positive 5. So I don't know what was going on right there. But that should really, let's go ahead and fix you. It should be a positive 5, which means this is a positive 5, which means I am not subtracting 5 here. I would be subtracting 5 here. Subtracting 5, giving me a negative 5. And now I've got the right answer. Negative 5 and negative 4 sevenths. Negative 5, negative 4 sevenths. Hooray, I got it. All right. Moving on to our last problem on the practice quiz, and I saw this and I don't know why I didn't give very much room. I assumed that maybe you could use the room over to the right, which I can in my case. I don't know if you can in your case. I apologize. I'll try to fix this for next year, maybe, if I can remember to do that. All right, so first two steps always are make sure that this side is 0 is step 1. So I'm going to go ahead and bring this 2v are going to come to the left. So I'm going to subtract 2v, and now you're gone. If I do something to the right side of the equal to sign, on the left side of this equal to sign, I have to do the same thing. I'm not going to write here. This would be a bad place to write minus 2v because these two terms are not like terms. I want to write my negative 2v underneath the like term. These are both a v term, so that makes more sense. So when I do that, the right-hand side of the equal to sign is a 0, which is our goal. So we can prepare to use that 0 product property. And I still have this minus 64. Now I have an 8v, and I have this... It's 20v squared. Okay, don't know why that is so low here. There you go. So from here, you might want to jump right into a ninja star, but something just feels weird about doing that, right? Like this number is gigantic. This number is gigantic. I would have to multiply those two numbers together and then look for that number on the multiplication table. And I don't think 64 and 20, while it might be on this multiplication table, so 64 and 20 is somewhere out there. Is 20 right there? Yeah, it is. While that is on the multiplication table, that's too big. You must be doing something wrong. I'll never make numbers that big. So that means I need to factor out the greatest common factor. So the greatest common factor for all of these, I can divide everything by 8. No, too bad. I can divide that by 8 and that by 8, but I can't divide 20 by 8, so I can only go by 4. Darn it. Okay, whatever. Divide by 4, divide by 4, divide by 4, which means, okay, so there's two modes of thought. My favorite way is just to divide everything by 4, because on the right side, 0 divided by 4 is just 0. And on the left-hand side, this makes it much easier. I can say that this is a 5v squared plus 2v minus 16. That seems much more manageable. Like, look how small that number is. 5 and 16, so much smaller. Now I am finally ready for a ninja star. And what type of ninja star? Because we have a leading coefficient of 5 and not just 1, we're going to be doing an advanced ninja star. So the way that we set this up, I usually do this off to the side. The reason that I put this off to the side instead of putting the ninja star down here is because I want to show how to get the progression from here to what is being factored without the ninja star getting in the way. So this is kind of our scratch work off to the side. And we're saying, I'm going to use the word combine instead of the word add, because I think that's a little bit more accurate. Two numbers are going to combine. Maybe if you don't like the word combine, you can say add / subtract. You're going to have two numbers that will add or subtract to 2, because again, you're just taking the middle coefficient and putting it over here. And I'm going to multiply 16 times 5. And if you don't know how to do 16 times 5, you can come over to the multiplication table, right? That's what we've been using all day. So I have 16 times 5, which again is that number 80. So you can come over here and say, oh yeah, I multiply those together and I get 80. And you'll be wrong, because it's a positive times a negative, so I need to make it a negative 80. All right, now I'm ready to go, and still setting up the ninja star. 5v is going to come up here to say 5v. Ninja star is finally set up. This is what they multiply to, by the way, just as a note. And again, this is kind of the fun bit where you're searching for 80. 80 on the multiplication table. I know it's going to be 8 and 10, but let's go ahead and be like, I'm searching for 80. Where could 80 be? And like, oh, 80 is right here. It's 20 and 4. You're like, darn it, but 20 and 4, that doesn't add up to 2. And by the way, they're going to subtract in this case. Why? Because it's a minus sign right there. If this is a minus sign, it's always going to be subtract. If it's a plus, or if this is a positive number, it will always be add. So in this case, I'm going to go ahead and preemptively be like, we're subtracting these two numbers, this number and this number, subtract them, and you'll get 2. So what two numbers subtracted, we'll get 2 at the same time multiplying to 80. And yeah, I'll go ahead and show you the answer. It's right there. 80 is 10 and 8, because 10 minus 8 is 2. So come back over here and say 10 and 8, which of them is negative? Well, remember, when you combine them, when you subtract them, they take the sign of the larger. That's the larger, and this is a positive, so the larger has to be positive. By process of elimination, that means that has to be negative over here. It's a negative 8. And then from here, I'm going to treat this as a fraction, right? That's a fraction, and we can reduce. So if I reduce that fraction, I can say divide by 5, and 5 and 8 are co-prime, meaning they can't be reduced. But this fraction can't be reduced. It's going to reduce down here to just v. You can say 1v, but I think v is easier. V, and then 10 divided by 5 is 2. So that means I'm ready to say that this is v plus 2. I'm going to get the sign correct this time. And the other one was a 5v minus 8. 5v minus 8, and that's going to be set equal to 0. Again, we're not done yet because I need to actually solve this thing. I'm running out of room, and I'm guessing that you guys are probably running out of room by now too, so I'm going to go ahead and do my work up here. And I'm going to say v plus 2 could be set equal to 0 is one possibility. The other possibility is, oh, that was a little bit too tall because I'm running into the room over here. So let me undo this. I'm going to come back and say, I'm going to come right here. There we go. So I can say that v plus 2 could be equal to 0, or I can say 5v minus 8. Or I can say 5v minus 8 is equal to 0. Whenever you're running into other problems like this, it's really helpful to me, the teacher, to section off that problem. Look, now it's really clear that I'm still working on problem number 7, whatever, or 6, whatever this problem is. All right, so these are the two problems that we're going to be solving. Pretty straightforward. Subtract 2, v is equal to negative 2, which is one of the two answers. And over here, we're going to add 8, and I'm going to get 5v is equal to 8. I haven't solved for v yet. I've solved for 5v, so I still need to get rid of that 5 by dividing by 5, and I get v is equal to 8/5. And that's my second of my two answers. Let's check negative 2 and 8/5. And that concludes our practice quiz 7.4. Thanks for watching.